All right, party people. So the last section I want to go over is this system of equations section here at the bottom, like 52, 53, 54, 55. 55, you're going to do specifically on your calculator. So there's a video on EDSB about how to enter that stuff into a matrix. So make sure for 55, you work on that. For 52, 53, and 54, let's just review the process for substitution, elimination, things like that. Graphing would be another option. So for number 52, it says determine the x coordinate of the system. Now, obviously, you could plug in x, solve for y, and then try to like figure it out. But you should recognize that this already has x solved for. So what I'm going to do is I'm going to substitute that in to the first equation. So I'm going to write 3. In fact, let me do this in text. 3, because that's the beginning. And then when I get to the x part, I'm going to write parentheses, and I'm going to plug in the value of x, which is 22 minus 3y. That's substitution. Minus 4y equals negative 25. Now, literally, I got rid of one of the variables x by substituting its value in. Now, this is a linear equation with one variable which can be solved. So I'll just distribute through 3 times 22 is 66, minus 3 times 3y is 9y, minus 4y equals negative 25. I'm going to combine my like terms. So I'll subtract 66 from both sides. And that will give me negative 9y minus 4y equals whatever that is. Negative 25 minus 66 is negative 91. Then I'll combine these like terms. Negative 9 minus 4 is negative 13. Negative 91. And then I'll divide by negative 13, and I'll get 7. So y equals 7. Now that's great, but the question did not ask us for y. It asked us for x. So make sure that once you have that, you're not getting tricked by the question, because you can clearly see B says x equals 7. So don't do that. Now take the second equation, which is x equals 22 minus 3y, and plug in y. 22 minus 3 times 7. So that's x equals 22 minus 21, x equals 1. So that right there is just an example of substitution. That is when we have one of the variables solved. In this case, we had x equals, so we just substitute that in for x. You can already see for number 53 that we don't have that. For number 53, we have this kind of muddled mess. So what I'm going to do is I'm going to erase this, and I'm going to write out my system again in text. X minus 6y equals negative 31, and negative 4x minus 3y equals negative 11. And now what I can do is I can do elimination, or it's called linear combination. I can manipulate one of these equations so that the x and y value on top or bottom match. So I'll give you an example first. I'm going to multiply this top equation by 4. The reason I chose 4 is because it's currently x here and negative 4x here. So once I multiply by 4, I get a pair of opposites, 4 and negative 4. I also could have multiplied the bottom by 2 or negative 2 because it would have given me 6 and negative 6, right? But now, after I do that multiplication, I end up with 4x minus 24y equals, and then negative 31 times 4 is negative 124. So what the heck was the point of that? Well, now this new equation and this original equation here can be added. This is called linear combination. You're adding the equations of two lines together, and the x values cancel. And because the x values cancel, I can now simplify the rest. So negative 3 plus negative 24 is negative 27. Y Negative 11 plus negative 124 is negative 135. And when I divide those, I'm pretty sure I'm going to get y equals 5. Or I'm sorry, y equals 7. No, maybe it's 5. 135 divided by 27 is 5, yeah. So that gives me y equals 5. And that is exactly what this question was looking for. So I eliminated the x variable by multiplying by 4. I use linear combination. So the first one is substitution. This one is elimination or combination. For number 54, it's asking how many solutions does it have, which is a little tricky because, again, lines could either have, well, letter D is not right because it is 2 lines. So they either have no solution, which means they're parallel. They have an infinite number of solutions, which means they're like the same line, or they have one solution where they cross one time. So it has to be one of those 3. It can't be 2 or something else like that. It has to be 1, none, or infinite. In order to solve that, you just do exactly what we did on the last question. So I'm actually going to do substitution again. See how I have this y equals 5x minus 1? I'm going to type in my second equation, 10x minus 2. And then when I get to y, I'm going to type in what y is equal to. So all I did was I took this, 5x minus 1, and plugged it in here. And then I get 10x minus 10x plus 2. That's negative 2 times 5 is negative 10. Negative 2 times negative 1 is positive 2. That equals 5. Now we can clearly see what's going to happen. 10x minus 10x is 0, so that cancels. So I get 2 equals 5. Now that right there, 2 equals 5, is obviously not true. So if you get a statement that's not true, there's no solution. That means these lines are probably parallel. If you were to solve this for y, 10x minus 2y equals 5, solve it for y, you would probably get, the same equation. So I think that's it. 55, remember, you're going to make your matrix, plug in your values, and yeah, it's all good. See ya.